Well, hello there. If you don't know who I am or what this is, then you can check out the last video. But you're not gonna do that, because I wouldn't do that either. That video sucks. So let me just give you a quick recap and we can continue from there. This is chess, and this is the FEN notation. What this means is this is basically a way to represent a chess position. So like any chess position, you can translate that into a string of characters like this one. And anything you do in chess, basically, you can do that. And you might be wondering, well, why do we want to do that? What's the purpose? So you can send your friends a screenshot of a chess game that you played that was really good. You can show them a position. You can create a puzzle, for them, and then you can just send them a picture of that puzzle. But computers don't like taking screenshots and sharing those with each other. They like to talk in terms of text. And this is where this comes in. This is how computers share chess positions with each other. And this can be used for like training AI, or I don't know, making puzzles and sending them to your friends so they can actually play the puzzles instead of just have a picture and then think about it in their heads. So I'm trying to create something like this for the game of Catan. If you don't know what Catan is, this is the game of Catan. See, I'm more prepared this time. That was a reference to the last video. In Catan, you have this kind of a board, and you have these tiles with resources on them and numbers on them, and then you can place your. Let me just get a thicker cursor. I don't know how to do that. Nah, forget about it. So you can place your settlements on there. You can build roads. You can convert these settlements into cities. None of these players have done that right now. This is a still from a Dandy Drew game. I might link that in the description of this video, and I might also link the FEN notation wiki page. Anyway, so we were about to make the notation, something like that, for Catan. This is the general information that we need. So far in the last video, what we did was we used these resources and these ports, and we assigned all of them these. Let me just do that. We assigned them these characters. So for wood, W, sheep, S, brick, B, grain, G. Grain is wheat, but that's the official name. Ore is O. 341 ports are just a 3, and the rest are wood, sheep, brick, grain, or the same. Now, I went through the process of actually writing down the rules that we covered in the last video. The board is divided into 5 ranks. So 1, 2, 3, 4, 5. Numbered 1 to 5, with the 5th rank at the top. We're following the example from chess. The ranks contain 3, 4, 5, 4, and 3 tiles respectively. So 3, 4, 5, 4, and 3 tiles respectively. The notation starts from the 5th rank. So it starts at the top. The first and last entry of each rank, except the third one, indicates the port type on its left and right side. So this port and this port for this first rank, this port and this port for this second rank. I know like this port is shared between the first and second rank, but it's mostly in the second rank. And this one's for the third one, the sheep port. This is for the fourth, these two, and for the last one, these two. So that's how you define the ports, the first and the last entry. Between the ports, every tile is described using 2 characters. The first character indicates the number on the tile. So you see these little numbers? Yeah. They represent 1 of 11 possible outcomes of rolling 2 6-sided die. These are the 2 dice. Here, let me just scroll that. These are the 2 dice that we need to roll. Yes. For the desert, okay. 2 6-sided die. These numbers can range from 2 to 12, represented using the hexadecimal characters 2 to C, because representing 12 using 2 digits is kind of annoying. We just need 1 character. So yeah, 2 to C. Since the desert has no number, a 0 is used. The second character represents the type of resource on the tile. It can be one of 5: wood, sheep, brick, grain, and ore. Since the desert has no resource, a white space is used instead. So you see this little space right here? No, wait. Oh yeah, this little space right here. I'm sorry, that wasn't a space. Yes. So the ranks are separated with a slash symbol. I highlighted this because in the last episode, we decided that, well, I decided that we're going to use slashes to represent the different ranks. But I've done some thinking, and we don't really need to do that, because in chess, They were using slashes because you could have, like, this represents the empty. Let me just bring that back. This represents the number of empty squares starting from the left. So this row has like 8 empty squares. So that's what this 8 would be representing. So you could do like 5, and then you can put a, you can do 5 and you can put like a pawn there, and then have like 2 more empty spaces, something like that. So we don't always know how many characters are going to be between the slashes. So we use slashes to separate, you know, those different sections. But in Catan, we are always going to have this exact number of characters in some different combination or permutation. Actually, that's interesting. Since we're only ever going to have these characters, we can actually use that to describe the total possible number of Catan positions that can ever exist. I just thought that was kind of interesting. So we just need to count the different unique characters that there are. I know the brick and number 11 use B, but we're going to treat them like they're different characters. And for the desert, we're not going to consider 0 and space. We're just going to consider the 0, because in the desert you can never have a resource, so wherever the 0 goes, the space will follow. Anyway, so we have 11 possible outcomes for the dice roll. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 11. And we have 5 types of resources. So that gives us a total of 16 different kinds of things that can be done, like, you know, the different numbers and the different resources. But the thing is, you can repeat numbers. You can repeat 11 and you can repeat 5 and 9. So it's going to be less than this number that I'm calculating. But it's okay. We can actually do that calculation. So we have, okay, let's just do this. We have 16 different things that we can have, plus a desert, which is 17. So that would be 17 factorial. Or all the math nerds out there. There aren't any math nerds, are there? There's probably no one watching this. Anyway, 17 factorial for the total number of things that are possible, and we divide that with all the repetitions that we can have. So we have 5s that can be repeated. I'm sorry if my camera is flickering. It's kind of daytime outside and I can't control the lighting effects on I'm using my phone as my webcam. If anyone knows how to fix that, let me know, because if I turn the hair and I turn back, it gets dark, and I'm sorry, I can't do anything about it. I tried a couple of things, nothing's working. I don't have curtains either. I'm sorry. Anyway, so we have 17 factorial here, and we divide that with the repetitions. So we have 5s that are repeating. So we're going to divide that by 2 times, because there's 2 5s. That's why 2. 2 times 9s are also doubled. 2 again, because there's 2 9s. And then we're gonna have, well, so we have 3s. Okay, let's just start from this. We have 3s, 4, 5, 6, 3, 4, 5, 6, 8, 9, 10, and 11. So everything except the 2 and the 12 gets repeated. Wait, 3, 4, 5, 6, 8. Oh, there's no 7. There's no 7. I forgot about that. Catan doesn't have a 7. Okay, so it's actually 10 different possible outcomes. It's one of 10 possible outcomes of rolling 2 6-sided die, except for 7. Catan boards don't feature a 7. How did I forget about that? Okay, yeah, I'm sorry. So it's actually 10 plus 5. So it's 15 different things plus a desert. So it's 16 factorial divided by, so yeah, 3, 4, 5, 6, 8, 9, 10, and 11. So that's 8 to the power of 8. So we can just do 2 to the power. Where's the stupid power? Where? Okay, 2 to the power of 8. So if we put that in a calculator, I have a calculator. If you put that in a calculator, 16. I should have looked this up before. Where's the stupid factorial sign? Oh, there it is. 16 factorial. Oh, that's a big number. Divided by 2 to the power of 8. Oh my god. Okay, so I'm going to type this down. So that equals to 8.173 times 10 to the, oh no, god damn it, to the times 10 to the 10th power. Dang, that's the total possible combinations of, or permutations, or like possible Catan boards that can exist. That's a lot of boards. Okay, that was a fun little math lesson for us all. Let's just add this. Yeah, why not? Possible Catan board configurations. Yeah, okay. So player pays. Okay, yeah. So far we had these rules. I was defining this board, and we created this example from a different board. We didn't use this board. So we're gonna actually use this board and create another example, just so we can, you know, get everything in place. So start with the port. The first port is a 3x1, so we do a 3, and then we do the tiles. So this is a 12, which is a C grain, so CG, and then there's a 9 sheep, there's a 10, which is A grain, and an 11 brick, a 6 grain, a 5 grain, and then an 8 or, oh shoot, I'm sorry. So after the 10 grain, we were supposed to do this port right here. That's the OR port. And then we should have a slash according to the rule, but I'm thinking we can do it without the slash, because again, the number of characters is always going to be the same, so we don't really need the slashes. They're just there to look pretty for us, but computers aren't going to do anything with them. It's actually more annoying for the computers if there are slashes. So it would be better from software purposes to remove the slash. So I'm going to do that. So yeah, we got the AG and then the OR port. Yep. And then we got the 11 brick, but instead of 11 it should be a B, so yes, BB. And then there's a 6 grain, a 5 grain, and 8 OR. Yep. Okay, and then we have a oh yeah, we didn't do the ports for the second ranked. What is up with me today? Okay, so we did the AG, I agree, and then there's the OR port, yes, and then there's a 3-for-1 port again. And then there's the 11 bricks, and then there's another 3-for-1 port, and then we do the 4 or are you 8? Are you a capital O? You don't look like the other O's. What's up with you? Okay, just 4 or 3 wood, 11, which is a B, or 4 wood, 3 brick, and then a sheep port, because the third rank only has 1, and then a brick port, and then an 8 sheep, and then a 10, which is an A, B brick, and a 9 wood. We then have the 0 desert, which is a space, and then a 3-for-1 port. Yep, and then a wood port, and then a 5 sheep, and then a 2 sheep, and then a 6 wood, and the last one is a 3-for-1 port. Okay, this is our new example for this board that we'll be using from now on. Okay, now on to the main topic of today. Oh my god, it's been a few minutes, right? God damn, I'm sorry for wasting some of your times. Hey, but we learned math. Math is important. Okay, so after we place all the tiles and all the numbers and the resources and the ports on the board, after that, when you start the game, the players put 2 roads and a settlement down. And the thing about the roads is that they're at the edges of every two adjacent tiles, hexagonal tiles. And the settlements or the cities also, they're at the corners. You can have a corner of 2 or 3 different tiles. So I actually wanted to do something like this. I wanted to like have a string of characters defining the whole, every single edge and corner available in the board, on the board, and I wanted to mark that as either a road or a settlement or a city, and to assign that to a player. But that turned to be really hard because I was trying to traverse the whole thing in one fell swoop, so we can have like a pattern that we follow when placing all of them, so we don't have to like store also the location of every single road and settlement, because that gets annoying, right? And I actually tried doing this. I spent like a lot of time, more than I should have, trying to like draw a pattern, like if you can see this, yeah, like draw a pattern like where I could go through the whole like board. I tried squares because it's a similar problem with squares. If you can do squares, you can do hexagons. So here's what I mean. Like I was trying to make like a shape that I could like, you know, go through and like cover all of them. And I would like get stuck here, or like I would go here and I would get stuck here. Like there's no, and I tried, like that's not the only way I tried. I tried having like woo or something like that. But you can only like close the whole thing once, and you need to close it multiple times. Like you can't not close it and like traverse the whole thing with just one close at the end. So it's a graph theory problem. If anyone, you know, is more knowledgeable on it than me, or if anyone wants to learn more about it, let me know. I don't know. But yeah, that was not possible. So what I did instead was the next best thing. Let's just do a rectangle. So what I saw was that every edge, not a corner, every edge could be divided into different sections. So we have 6 edges here. We have 1, 2, 3, 4, 5, 6, so 6 possible roads. And then we have these vertical possible roads. So there's 1, 2. Actually, I know you can see 2 vertical lines, but only one road can go there. So like that's 1 for us. So like 1, 2, 3, 4. So we have 6. And then for the verticals, we have 4 here, and then we have 6 plus 2 more, I'm guessing, or like 3 more. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so we have 8. And then again for the verticals, we have 1, 2, 3, 4, 5. We have 5. And then it's a similar kind of a thing, and you can see where I'm going with this. So first, for the tiles, we were dividing them into 5 ranks. So like this is 1 rank for like 3 tiles, and then this is 1 rank for 4 tiles. But now what I'm trying to do is I'm dividing them even more into more ranks. So for this part, for this section of the whole thing, we use 5 ranks. But for this part of it, we use 1, 2, 3, 4, 5, 6, 7. I'm sorry. 8. I don't know how many that is. I'm counting right now with you guys. So 9, 10, 11. We have 11 different. What are you? Did I do something wrong? Okay, I'm so sorry. Yeah, so we have 11 different sections that we can use. So okay, that's helpful. So let's try to utilize that. So for player placement rules, we can start with, let's just copy this and like create another example. Oh no, should see. Yep. Okay, example. So let's just try to plot all the different like roads. So I'm gonna like what I was thinking is what we can do is borrow a concept from chess. So remember how you have this 8 here for all the empty squares that there are? We can use something similar for all the non-road edges available to us. So what we can do is we can have 1, 2, 3, 4. 4 empty edges followed by a settlement. Let's use an S for a settlement. It's a blue settlement, and that is important because, as you can see, each player gets their own color and their own settlement. But the thing is, in Catan, at least in Colonist, you can have a lot of different colors for the players, but there's always going to be 4 players. So instead of using colors, I think it would be better if we used numbers. So that way you can assign players different colors, and you're not limited by what the FEK notation indicates. So yeah. Instead of 1, 2, 3, 4, we can maybe do A, B, C, D. I don't know which would help us more. But for now, let's just use 1, 2, 3, 4, because why not? Actually, A, B, C, D might be better because then we don't have numbers. And like right now, we're using numbers to indicate the number of empty spaces. So yeah, let's use A, B, C, D actually. So we have 4 empties followed by an S, which is a settlement. And the settlement is blue. Or, oh, sorry, let's just, what player are you? It's player 4. Okay. So D, 4th player, D, SD. 4, SD. And then we have 1, 2. 2. So that's our first rank. And here we actually do need slashes because this can vary. This could have just been 6 instead of 4 SD2. So we don't know what the length of the whole thing is going to be. So for here, we actually do need the slashes like in the chess thing because again, it can vary from number to number. And even in these ranks, like it's PPPPP, but it could have empty spaces as well. So yeah, let's do that. So we have 4 SD2, and then we have in the second rank out of 10, we have 1, 2 empties, and then a road. So a road, let's use R, and that's also for D. And then we have 1 empty road space. So 1 empty, another slash. Yep. And after that, let's do this one. Yep. So we have 1, 2, 3, 4 empty road spaces, followed by a settlement. There it is. And that settlement is first player. Red is first. Yep, red is first. Let's just put it kind of here. Yeah. Oh my God, this is perfect. Yeah. Let's just put it here so you can see the players. Red is number 1. So we do A, settlement A, and then 1 empty space, and then a road. So a road for D. RD, settlement A, 1 RD, yes, 1 empty space, and then there's a road for D, and then there's 2 empty road spaces. Slash. Oh God damn it. Slash. Yes. So we've done the first 3 ranks. 1, 2, 3. Yep. And now this one, 1 empty space. And then we have a settlement. So the settlement is always going to be at the lower side. So if you're going from here, it will be after the spaces. So after the 4 empty spaces, there's going to be a settlement. And for the vertical ones, it's always going to be at the bottom because the top is always counted for in the previous rank. So that's why we're going to have for the vertical edges, the settlements that we place are always going to be at the bottom. Oh, but here's the thing. So for the vertical ones, we put a settlement down. Oh yeah, okay. So for the vertical ones, the settlement's going to be at the bottom. So it's going to be down here. And for this, oh, that's kind of concerning. Okay. Because that's the thing. For verticals, we can have, okay, here's the idea. Okay, here's the idea. I got this, guys. Don't worry, I got this. So for every rank that isn't a vertical, so we have two kinds of ranks: vertical edges and tilted edges. I don't know. Yeah, tilted edges. So settlements will always be touching at least some tilted edge. Always, like every settlement is going to have a tilted edge, and every settlement might or might not have a vertical edge. Oh, actually, is there a way for it to not have a vertical edge? Right over here. So on top here, it might not have a vertical edge, but it will always have tilted edges, no matter where you are. So let's just do this. For every rank that concerns tilted edges, we account for settlements and roads. But for every non-tilted edge, for every vertical edge, we only do roads. So for the first one, it'll become 4 as settlement for D, and then there's 2. Perfect. And for this, it's going to be 2 empty spaces followed by 1 road. Okay, 4 empty spaces. No, it's going to be 2 empty spaces. Sorry, 2 empty spaces. And then there's a road for D, and then there's 1. Yes, perfect. So there's going to be 1, 2, 3, 4 empty spaces, and then the settlement for A, and then there's 1 empty road space, and then there's a road for D. Yes, road for D. And then there's a settlement for D as well. Yep. And then there's 2 empty spaces. Perfect. That works. I'm saying yes a lot, aren't I? I learned that from my friend Ahmad. I'm trying to unlearn it because I don't like saying yes a lot. It's like, so we do this, yes, and it's not fun. Okay. I like okay. Yeah. Also, I'm trying to underdo the is like, it's a filler word that doesn't mean anything. I don't like to use it. It just wastes time, you know? Also, you know, I'm gonna stop now. Four. I was gonna say okay. Four for the third rank. Okay, perfect. So just like the chess thing, we have finished technically the second section of the FEK notation. So far, we've finished with the board placement, the tiles, the numbers, the resources, and we finished with the player placements, the cities, the settlements, and the roads. So yeah, next time we're gonna do resources, and that's gonna mean how many cards each player has in their hand, how many cards are there in the deck, how many development cards are there in the deck, how many development cards does a player have, and finally, how many knights and how many knights each player has played, and the longest road will be calculated in the software part, so we don't need to store that. And then we just save the information on the active player whose turn it is, and the statistics for the dice rolls so far. Why that's important, I'm going to tell you that next time as well. So yeah, see you guys when I see you. This was fun. Bye bye.